Hello friends, previously we are studying the CH group disconnection in such a way that we are getting a stable fragment. So here we are going to study our next molecules or next points one by one. We are studying the CH group disconnection in carbonyl compound. So we are reach up to the carbonyl compound, how the disconnection could be occur, and we are getting a stable fragment. So this is nothing but one group CH disconnection in carbonyl compound. So look at here. Here is the carboxylic acid. On that we are proceeding a different reaction, and we are getting different starting compound. So the easier and readily available compound is nothing but this acid chloride. On acid chloride we are doing different reaction, and we are getting different starting material as well as different reagent, as well as we are getting different products from that. In retrosynthesis approach we have to study the acid chloride in easier way. We know we have to study how we can getting a acid chloride, or on reaction with acid chloride we are getting acid anhydride as well as esters as well as amide. So we are doing different reaction on acid chloride, and we are getting our starting compound easily. So we have to know that how the acid chloride could be obtained from carboxylic acid. Here showing how the reaction could be occur when we are reacting carboxylic acid with ROH or any alcoholic group. We are getting our ester compound. So after when we are doing a hydrolysis reaction or acetylation reaction, on that we are getting this anhydride compound. On reaction with SOCl2 or PCl5 we are getting our acid chloride compound. So here is a showing reactivity of the given compound. Here acid chloride is most reactive and mostly useful starting compound in our given reaction. So we know that how we could obtain acid chloride from a given reaction or from given compound. So we can study the reaction of carbonyl compound or fragmentation of carbonyl compound by one while studying the different examples. So when we are doing a retrosynthesis we have to know which group is electron donating group or which group is electron withdrawing group, or we know the reactivity of given compound, or always we know that how we can transfer one compound into another compound by using different reagent, different chemicals. We are getting different compound or specific compound. There are different compound which are a specific compound from which we are getting our desired compound. Here is a all methyl groups or NO2 group are given here. We know that methyl group is orthopara directing group, as well as whenever we are studying any electron withdrawing group, then electron withdrawing group must be stabilized on meta position or on meta position. So we have to know all the reactivity or reactivity effect of the given compound, so as we can proceed we can use it in our synthetic steps. So here is a, we know that methyl group is orthopara directing group. When this methyl group react with KMnO4, it convert to acidic group, which is nothing but meta directing group. Or when this methyl group will be react with SBF5, which would be proceed to electron withdrawing group, which is also meta directing group. So we know that how we could proceed our reaction, or how we could transfer our starting compound into another compound. We always remember that there is a, when we are doing any transformation of a given compound, the reaction could be proceed through one compound to another compound by using different reagent. Here is a NO2 group. On NO2 group we are proceeding a ConHCl as well as H2PDC. So here we are transforming NO2 group into NH2 group or on amine group. So we know that how to transform one group to another group by using different reagent. So always remember the effect of the given compound one by one, so as we can transform one molecule to another molecule. So after that we are going to study the example one by one. So here is a simple example. On that we have to do fragmentation. We are studying that we are doing a fragmentation to carbon and heteroatom bond. So in this case we do not want to do a fragmentation through this carbon and heteroatom bond. Whenever there is a presence of Rx group, in that case we have to do the fragmentation. Here is a given a CCl3 group. Here is a electronegative group. So on that group we have to do a functional group interconversion, or we have to do a chlorination reaction. On when we are doing a chlorination reaction, we are getting this compound. So we are getting this starting material, so we have to do a chlorination reaction on that compound. So we are doing here a, here is a formation of this CH3 group. This methyl group is nothing but electron donating group. Electron donating group means it will be direct the substitution reaction towards ortho as well as para substitution on a benzene ring. So we are getting our compound. We have to do fragmentation in such way that we are getting a stable compound or stable starting material. So here we are doing a fragmentation further to this toluene compound. So this methyl group, as we know that it is ortho para directing group. When we are doing a chlorination reaction on this benzene ring, this chlorine group could be substituted on para position. So we know that where to do fragmentation, we are getting a stable fragmentation, so as to we could proceed a synthesis on a given molecule, or we can get a easily available starting material. We have to do retrosynthesis in such a way that we are getting a stable fragmentation, and we are getting a easier product, so as to we have to proceed our synthesis in easier way and finer way. So the next is synthesis. So we are getting a toluene which is readily available starting compound. Here is we are getting our toluene compound. When this toluene is react with this Cl2 and FeCl3, which is nothing but a chlorinating reagent. So here is the reactivity of methyl group is important. This methyl group is ortho para directing group. So here is the presence of 2 ortho position and 1 para position. So the incoming group must be substituted on the para position. So here we are getting our Cl. When after that this Cl group is electron withdrawing group, which is also para and meta directing group. So when this group is present, then there is on this compound we are proceeding a chlorination reaction. When we are proceeding chlorination reaction, here is we are getting CCl3 group as it is. So when we are doing SbF5, or we are previously doing a functional group interconversion. So here in this case we are doing a reagent SbF5 and we are getting this compound or fluorinating compound. This is synthetic step. So here on toluene we are proceeding reaction and we are getting this compound or starting compound. This is another example we have to study of biphenyl compound. Biphenyl compounds is easily available starting material while doing our synthesis. So when we are going to study a biphenyl compound, we have to know their reactivity, their reaction position in a given compound. So here is some examples we can study of this biphenyl compound. Here we are they are giving our starting material. In this case, here is a acid group. The acidic group could be converted into cyanide group. For this conversion, we have to know the reagent, how we could proceed one functional group into another functional group, or we know the reagent to convert the acidic functional group into cyanide functional group. Here is after that the cyanide group could be converted into NH2 group. So here is a diazotization reaction. You have to remember all the steps and all the reaction which you are studying till now. You have to know how the intermediate form, how the carbonation reaction, acylation reaction, and different intermediate or different name reaction you have to know properly, so as to you could transfer your given compound into another compound, or you can proceed the diazotization reaction as well as different nucleophilic substitution reaction, addition reaction in our given compound. In this case, cyanide is transformed into NH2 group. So on this NH2Cl group chlorination, here is a, after that there is a fragmentation through this. So we are getting this biphenyl compound. On biphenyl compound we are doing the nitration reaction. Here the NH2 group again converted into NO2 group, and after that we are doing fragmentation through this. So we are getting this biphenyl compound, which is readily available or easily available our starting material. So after that we have to do synthesis on your given molecule. Always remember that end product of our retrosynthesis is always our starting product of our synthetic reaction. So in this case the biphenyl is our starting compound. On biphenyl compound we are doing a nitration reaction. So NO2 group could be attached here. After that we have to do SnHCl or H2PDC. So we could convert NH2 group into NO2 group into this NH2 group. After this doing this, here is a 2 ortho position. So to get our given starting material, we have to block the reactivity of this NH2. So here is a, we are using a protecting group Ac2O, which is nothing but a protecting group for amine compound. So this NH2 group could be protected. So protection and reprotection is another types of reaction in which the reactivity of one molecule could be blocked for several times to get our desired product. Here is the when we are doing the acetylation reaction here, then the NH2 group could be blocked or their reactivity will be blocked. So after that we have to take a chlorine molecule here. So we are doing a chlorination reaction. After that we are getting chlorine molecule here, or we can proceed is through acidic. Here is the presence of acid. Acid is given to deprotection of given molecule. Here in first step we are protecting this amine group. In next step we are deprotecting that amine group by using acid. Here is the presence of H2O or H3A or any acidic group will be given to deprotect our given molecule. So after that we are getting here our, up to this we are doing the synthesis. After that we are going to convert the given NH2 molecule into CN molecule. This is nothing but diazotization reaction. In this case this is nothing but diazotizing reagent. Here they are giving diazotizing reagent. So we can convert NH2 group into CN group. After that here they are giving NaOH group or acidic group to convert the CN group into COH group. So this is the easier way to do synthesis as well as retrosynthesis in given molecule. So we have to know that how the reaction could occur and how we can transfer one molecule or one functional group into another functional group. So you have to study all the FGI interconversion. So here is given the another compound or their fragmentation, which is also easier. So here is we could proceed fragmentation through this bond. Here is the presence of heteroatom bond or carbon heteroatom bond. So we could break the heteroatom bond first and doing our synthesis. After that we are getting this amine compound. So after that we have to convert this NH2 group into NO2 group. So we can proceed nitration reaction easily. So after FGI we are breaking this bond here, breaking of this bond. Here we can break the bond through this. We can break bond from this and we are getting 1,2-dichlorobenzene, which is also easily available starting material. So this is our retrosynthetic step, or we can fragment the given molecule in easier way or in such a way that we are getting easily available starting material. After that we are firstly doing a retrosynthesis. We can fragment the molecule like this so as to we are getting a stable product. So here from 1,2-dichlorobenzene we have to proceed, we have to make our given starting material. So in this case, when we are doing a nitration reaction on this 1,2-dichlorobenzene, here is a, we have to know that how the reactivity of this chlorine group. Chlorine group is electron withdrawing group, so it could be react at ortho meta position. So here is the presence of, this is also ortho position, this is also ortho position, this is meta position, this is also meta position. So we are getting two position. So we have to do reaction on one meta position, any one meta position. So we have getting our compound. So we are doing, in this case we have to know how the reactivity of a given compound could be obtained, or how the reaction could be proceed, so as to we are getting our compound. So here we are getting this compound, then reduction of this NO2 group to NH2 group, then after that react with acid chloride, then we are getting our starting compound. Here the synthesis could be showing to you. Here presence of two chlorine group. So we have to do nitration reaction. If we are doing nitration reaction in this position at ortho position, here is a formation of steric crowding. Due to steric crowding, this reaction could be blocked at ortho position. So this could be proceed to a meta position. So on nitration on meta position, we are getting our compound. So we are getting our nitration or NO2 group at meta position. Then on reduction of this NO2 group to NH2 group, then react with this chlorinating group, then we are getting our starting compound. This is the easier way to do synthesis. Always remember, different methods will be obtained, or different methods will be available to do synthesis as well as retrosynthesis. We have to do synthesis or as well as retrosynthesis in such way that we are getting easier product. So here the how the actual synthesis could occur, here is showing this NO2 group could be converted into NH2 group. Here how the reaction could proceed, here showing how the mechanism could be obtained while we are doing our synthesis step. So this is easier way to do synthesis in given molecule. So this is the easier way to do a synthesis in given compound. This is another compound. So in this case we have to do a fragmentation in such a way that we are getting a stable fragment. Here is another simple example. Here molecule could be break from this heteroatom bond. We are getting a stable fragment. Here we are getting this alcohol. So firstly we are doing our fragmentation or disconnection in given molecule. After that we are doing a synthesis. So in this case how the synthesis could be proceed, here given from this compound. So we have to know how the synthesis could be obtained. Here this alcoholic functional group or lone pair of this electron could be attack on this carbonyl group, opening of this carbonyl group, formation of negative charge. Here we are getting the second compound or intermediate compound. This negative charge could abstract this oxygen or this hydrogen atom. After that, here is the formation of this OH bond. The lone pair of electron could shift here and opening of this bond from oxygen and formation of this alcohol. After that, the negative charge could abstract intramolecular hydrogen abstraction, or we can call it as proton transfer reaction. After proton transfer, we are getting our starting target molecule as it is. This is nothing but another way to do retrosynthesis on a given molecule. This is another way, or this is another example of retrosynthesis. So we have to know, or we have to do synthesis in such a way that we are getting a stable fragment or stable compound. Here they are showing you a two way of fragmentation, A as well as B, but we have to analyze, or we have to know that which way would be easier to do a synthesis in a given molecule, so as to we are getting a stable fragment. So here from A we are doing a fragmentation through this, from B we are doing fragmentation from this. This is a we are from A we are getting a unstable compound, which is unstable compound. So we have to do a fragmentation in such a way that we are getting a stable as well as reactive compound. So we are doing a retrosynthesis through the path B. So after that we have to know we are doing a fragmentation like this. So after we know that the end product of our retrosynthesis would be the starting material of our synthesis. So here in this case, when the base react with this, base can abstract this hydrogen atom from this compound, then the negative charge react with or attack with this compound and this chlorine group will be removed. We have to know how the reaction could be occur. Here when the chlorine group is removing, then we are getting our target molecule. This is nothing but total reaction is called as Williamson's ether synthesis. This is when we are studying the Williamson's ether synthesis. So this is another example of retrosynthesis analysis. So in this case we are doing a fragmentation here in such a way that we are getting a stable compound. Always remember we are doing a fragmentation in such a way that we are getting a stable compound, or we have to break CX bond or carbon heteroatom bond so as to we are getting a stable compound in a given molecule. Here we are doing a fragmentation here and we are getting these two fragments or synthons. While studying a synthons we are getting a synthetic equivalent. We are doing a fragmentation on given molecule and we are doing disconnection. So after disconnection, here look at here how the lone pair could attack and this bromine group will be removed. Here a synthesis of a given compound. So given compound could be synthesized like this. This lone pair of electron could attack on the given compound. So this base could attract the hydrogen atom from the oxygen or OH atom. Then the negative charge could attack. Here is a formation of this negative charge. This negative charge can attack on this group and removing of this Br group. So we are getting easily our target molecule. We have to know how we are getting a target molecule in a given compound. These are the different way or different examples which we have to study while studying our reaction. In this case, here is a find out the bond which where we have to break in a given compound. Here is the presence of this is sulfur is nothing but our heteroatom group. So we have to break molecule through this. So we are getting these two stable compound. So as to we have to do retrosynthesis or disconnection on given compound. Then after that synthesis. So here is a presence of NOT which can abstract this hydrogen from this sulfur group. So here is a formation of negative charge. The negative charge could attack on this chlorine group, and this chlorine is which is nothing but good living group which can be lived easily, and we are getting our starting target molecule. Here is another way, another example of doing retrosynthesis. Here is a giving two nitro group and you have to proceed a retrosynthesis on given compound. This is this example for you for your homework purpose. You have to do synthesis as well as retrosynthesis on this given compound. Thank you. This is the end of our lecture. In next lecture we are studying next phenomena of retrosynthesis analysis. Thank you so much.